Hi everyone, we have one last tricky detail to deal with transformations. I think I might have said that the last video covered the last tricky detail, but I lied. There is one more. And that is that anytime you have a horizontal shift combined with any other horizontal transformation, so stretch, reflection, or compression, they interfere with each other. The good news is that this is actually a really easy fix. The only issue is remembering that you have to do it. So let's look at this. This is a great example. I have W of 2x minus 6, and I'm given the W graph. It actually looks like a W, so aptly named. And if I was just going to dive right in, I would look at that 2 and say that's in the parentheses, so that's affecting x's. And when I multiply x's by 2, I get horizontal compression by 1/2. And the other thing I see happening there is I'm subtracting 6 from x's. So I would look at that and think, okay, backwards. So it's actually going to go right 6. The problem is if you actually do those steps, you do compression and then shift, you will not get the correct graph. It does not look like something that has been shifted to the right by 6. So there are actually two possible ways to deal with this, and I will tell you both, but then I will choose the second one and stick with it. One option is to reverse the order that you do horizontal transformations. So you could shift to the right 6 and then do a compression, and it would actually smush your graph back into the right spot and give you the correct answer. The one that I'm going to use is we can do a very simple algebra step first, and once we do that, we can stick with the same order of operations for X transformations and Y transformations. We will just always shift last, as I've been saying. So that simple step, that simple algebra step, is to factor out the coefficient of X. So within those parentheses, we're going to factor out a 2. It'll give you a second set of parentheses, and it will turn it into 2 times X minus 3. This does not change what the 2 is telling me. It's still telling me horizontal compression. Just because I put an extra set of parentheses doesn't make that vertical. The set of parentheses that matters for that is where it always was. What's really important is that the shift now appears to be a shift by 3. And if you're sticking with the shift last order, that will be the correct shift. So again, if you have horizontal shift combined with horizontal stretch, reflection, or compression, you have to factor out the number in front of X to get the correct shift. Once you've done this, we just continue as usual. So I'm going to start with horizontal compression. That means I'm going to cut all my x's in half. So negative 5, 3 ends up at negative 2.5, 3, close circle. The open circle at negative 1, 3 ends up at negative 1/2, 3. The corners of the W, we were at negative 4, so that one moves to negative 2. And then the corner that was at negative 2 is going to get cut in half and move to negative 1. And if you want to, you can even follow this little corner right here. I should use my highlighter. This one was at negative 3, so that's going to land at negative 1.5. It should still look like a W. I'm going to redraw my open circle because it doesn't look very open. So I'm still expecting a right side up W. I just made it skinnier, right? I cut all my x's in half. So there is the horizontal compression. Now I need to shift everything to the right 3. So I guess orange will be my final graph this time. If I pick up the point, where was that? Negative 2.5, 3, and move it to the right 3, it will end up at positive 1/2, 3. So I'm going to label that one because this is a final graph. If I pick up this bottom corner, it was at negative 2, and I slide it over 3, it will end up at positive 1, 1. That one's right on a grid line, so I'm not going to label it. If I pick up, what was this, negative 1.5, 2, it will end up at positive 1.5, 2. I'll label that one, so that's 3/2, 2. And then 2 more to go. This one has more important points than some of the ones we've been working on. If I pick up the bottom corner, so that was at -1, 1, and I slide it over, it will end up at 2, 1. And then last but not least, the open circle was at -1/2, 3. So when I slide it over, it'll land at 2.5, 3, where I've written things right in my way. So open circle is at 5/2, or 2.5, 3. And again, I expect it to still look like a W. I've just slid it over to the right 3 units. So that would be my final picture for this one. So the transformations haven't changed, but remember the factoring. That still holds even if it's just a negative sign. So once again, I see a horizontal shift. My first thought is to the right 3, but I also see a horizontal reflection. So I'm going to start by factoring that negative sign out, which means you're dividing a -1 out of everything. So it should become an x plus 3 this time. So this one needs to flip both directions. So I see flip over x-axis. I also see flip over y-axis. Again, don't get confused by the extra set of parentheses. The parenthesis that matters for deciding whether it's changing x or y has not changed. I just added an extra set in there. So that is still inside the parentheses and flipping my x values, not my y values. And then last, now that I've factored, let's use green. I'm going to shift to the left 3. So I would have gotten the direction wrong if I didn't factor this one out. I think I'm going to do the flips both together, and then we'll do the shift separately. If I take a point like -5, 3, and I flip upside down, I get -5, -3, and then I flip across, I get +5, -3. So we will do 5, -3 as the closed circle. That's where the closed circle lands. I think I'll do the open circle next. The open circle starts at -1, 3. So if I flip upside down, it will land at -1, -3. And then if I flip across, it will end up at +1, -3. So an open circle at 1, -3. I guess that's on a grid line. I don't really have to label it. The bottom left corner, let's take that one next. So that is at -4, 1. You could flip upside down to -4, -1, and then across to +4, -1. So a corner at 4, -1. The very center of the W starts at -3, 2. So it's going to flip to -3, -2, and then over to +3, -2. -2, 1 flips upside down to -2, -1, and then that flips across to +2, -1. So that is my final corner. And since I've flipped both ways, I am expecting an upside down W, so these points do seem reasonable. It goes about like that. So now it's an M. I'm not done though. I do have one more transformation. I need to now move all these points to the left 3. So my open circle will land at -2, -3. The next point over was at 2, -1, so it will land at -1, -1. The middle of the W was at 3, -2, so it will land at 0, -2. The top right corner was at 4, -1, so it will land at 1, -1. And then last point is 5, -3, so it will land at 2, -3, and that's our closed circle. So our final location for our now M is actually centered on the y-axis. That is my final graph. So watch out for when that factoring is needed. Otherwise, I think you should have a pretty good start on transformations. Thanks for watching.